Atoms are the tiny building blocks of everything around us. Scientists have always been curious about them. Before Ernest Rutherford's famous experiment, our understanding of atoms was quite fuzzy. Imagine a blueberry muffin. Scientists used to think atoms were like that, with positive and negative charges spread evenly throughout, like blueberries in the muffin. This was called the plum pudding model. This model, proposed by J.J. Thomson, was a good starting point. But in the world of science, even the most accepted theories can be challenged. Enter Ernest Rutherford, a physicist who would change our understanding of the atom forever. With his ingenious experiment, he was about to shake things up in the world of atomic physics. His work would lead to a dramatic shift in our understanding of the atom and pave the way for future discoveries in the field. Rutherford and his team designed a clever experiment to test the plum pudding model. They fired tiny particles called alpha particles at a very thin sheet of gold foil. Imagine a piece of paper so thin you can almost see through it. That's how thin the gold foil was. Alpha particles are much smaller than atoms, but they have a positive charge, so they are like tiny bullets of energy. If the plum pudding model was correct, the alpha particles should have passed straight through the gold foil with little or no deflection. After all, the positive and negative charges were thought to be evenly distributed in the atom, so there wouldn't be any strong, concentrated areas of charge to interact with the alpha particles. The results of the experiment were truly shocking. Most of the alpha particles did pass through the gold foil as expected. However, a small number of alpha particles were deflected at large angles. Some even bounced straight back. Imagine throwing a tennis ball at a piece of tissue paper and having it bounce back at you. This was unexpected and completely contradicted the plum pudding model. Rutherford famously remarked, "It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you." These unexpected results sent shockwaves through the scientific community. To explain these astonishing results, Rutherford proposed a revolutionary new model of the atom. He concluded that the atom is mostly empty space with a tiny, dense, positively charged center that he called the nucleus. This nucleus contains most of the atom's mass. He also proposed that the negatively charged electrons orbit the nucleus at a distance, much like planets orbiting the Sun. This model, known as the nuclear model or the Rutherford model, became the foundation for our modern understanding of the atom.